Now let us solve problems related to projectile motion. This is an example of a problem related to projectile motion, wherein a cannonball, which has a mass of 12 kg, is projected horizontally from a height of 22 meters and covered a horizontal displacement or range of about 300 meters. The stated problem can be solved using the following equations. For the x component or the horizontal component, we can use this equation. D sub x is equal to Vx times time, where dx is the horizontal displacement or range, and Vx is the horizontal velocity, and t is time. For the y component, take note that the initial vertical velocity is 0. So you can use the following equations. D sub y, or vertical displacement, is equal to 1/2 gt squared, where g is the acceleration due to gravity and t is time. Dy is equal to Vfy times time over 2, where Vfy is the final vertical velocity. And finally, Vfy or V final velocity, vertical velocity, is equal to gt, or acceleration due to gravity times time. Using GRESA, let us solve some problems related to projectile motion. Problem number 1. A package is dropped from an airplane 344 meters above the ground. If air resistance is neglected, how long will it take the package to reach the ground? So let us now identify the given. So the given are the vertical displacement, negative 344 meters since the package is falling down. Then the acceleration is negative 9.8 meter per second because it indicates that the direction of the acceleration is downward. For the required, it is the time it takes for the package to reach the ground. The equation is time is equivalent to the square root of 2d sub y over g, or 2 times the displacement, vertical displacement, over acceleration due to gravity. Then, we get the square root. For the solution, we write the equation t is equal to the square root of 2 dy over g. Substituting the given quantities, square root of 2 times negative 344 meter divided by negative 9.8 meter per second will give you an answer of 8.38 seconds. Problem number 2. A soldier fired his gun horizontally from the top of an 80-meter high building with a velocity of 400 meters per second. Neglecting air friction, how far from the base of the building will the bullet land? So the given quantities are vertical displacement, which is equivalent to negative 80 meter, horizontal velocity, which is equivalent to 400 meters per second, and g, or acceleration due to gravity, negative 9.8 meter per second. Since the question requires how far from the base of the building will the bullet land, we are looking for the horizontal displacement or range. The equation for range or horizontal displacement is Vx times time, or horizontal velocity times time. For the solution, in order to find the range or the horizontal displacement, we need to solve first for the time. So using the equation square root of 2 dy over g, we substitute the given quantities. Square root of 2 times negative 80 meter divided by negative 9.8 meter per second, you'll get a time of 4.04 seconds. Now you are ready to solve for dx. So dx is equal to Vx times time. So that is equivalent to 400 meter per second times 4.04 seconds. So the dx, or the range, is equivalent to 1,616.24 meter. Problem 3. A movie stunt driver on a motorcycle speeds horizontally off a 50-meter high cliff. How fast must the motorcycle leave the cliff top to land on the level ground below? 90 meters from the base of the cliff where the cameras are. How fast vertically will he land on the ground? Ignore air resistance. To solve this problem, let us first identify the given quantities. dy, or vertical displacement, negative 50 meter. dx, or horizontal displacement or range, 90 meter. G, or acceleration due to gravity, negative 9.8 meter per second. For the required quantities, we have two, Vx, or horizontal velocity, and Vfy, or vertical final velocity. For the equation, Vx is equal to dx over t, Vfy is equal to gt. Since two equations require time, we need to solve first for the time. So the equation for time is square root of 2 dy over g. Substituting our given quantities, square root of 2 times negative 50 meter divided by negative 9.8 meter per second. And the answer is 3.19438 seconds. Now, you can substitute this time to the equations for Vx and Vfy. For Vx, so Vx is equal to dx over t. So dx is 90 meter, t is 3.19438 seconds. So Vx is 28.17 meter per second. For Vy, so Vy is equal to gt. So g is negative 9.8 meter per second. T is 3.19438 seconds. So the answer is Vfy is equivalent to negative 31.30 meter per second. That ends our problem-solving activity for projectile motion.